Good day, Engineer Sudweste. My name is Ralph Lawrence D. De Guzman from BSAT 31. Here we are tasked to answer some of the questions regarding the module number 1, Standard Atmosphere. And here it goes. To set the standard altitude. So firstly, let's talk about altitude. So altitude is a measure of an aircraft's height above sea level. So as we all know, there are certain factors that needs to be considered about altitude. So there are things like temperature, density, and pressure that can be detrimental, that can have a detrimental impact on an aircraft performance. So I think it is necessary to set the standard altitude for us to have a common reference in which an aircraft is in its best condition and having its best performance. There are different types of altitude, namely geometric altitude, absolute altitude, geopotential altitude, pressure altitude, density altitude, and temperature altitude. So let's talk about geometric altitude. So geometric altitude is referring to the actual altitude measured from the sea level or from the ground. So the second one, absolute altitude, it is that altitude measured from the center of the earth. The third type of altitude, known as geopotential altitude, is the altitude wherein we assume that there is no change in terms of your gravitational acceleration. The fourth type of altitude, namely pressure altitude. So it is the type of altitude that refers to how it responds to ambient pressure. On the other hand, density altitude is referred to how it responds to ambient density or yung density ng air dun sa area na yun. Lastly, temperature altitude. So ito naman, nagko-correspond naman siya sa ambient temperature. So ganun lang kasimple. Third question, is it possible to that geopotential altitude is equal or same in terms of value with geometric altitudes? If yes, then when and how? So based on what I read on an article, aircrafts use hydrostatic equation to determine the height or the altitude because pressure can be measured with a specific equipment that planes have. So using that equipment, airplanes measure the pressure, and with that they can put it into the equation and solve for the height. However, gravity is not the same at different altitudes, and it varies and it changes with respect to the altitude. So it is very difficult for an airplane to measure gravity in the air. Therefore, airplanes generally measure geopotential altitude. So ito, the geopotential altitude uses gravity at sea level and takes it to be constant, where geometric altitude uses gravity at the point of measurement. So with that being said, it is possible that geopotential altitude and geometric altitude will be the same in terms of value in some cases where pressure or gravity is not the same at different locations. Fourth question. Describe the relationship of the properties of air whenever the altitude change. Okay, so whenever the altitude change, different properties of air reacts differently. First, the density. The density of the air decreases with height. So there are two reasons. First, at higher altitudes, there is less air pushing down from above, and gravity is weaker farther from Earth's center. So at higher altitudes, air molecules get spread out more and air density decreases. In terms of air pressure, the pressure of air decreases with altitude also. So there is less air pressing down from above the higher up you go. In terms of temperature, it is complex. It depends on the geographic location, the date, the weather conditions on that area, and so on and so forth. But in a standard manner, temperature also decreases as altitude increases. Okay, so now, pag-usapan naman natin kung paano madederive yung hydrostatic equation. So dito meron tayong given na object na may volume na 1 by 1 times 1. So, alalahanin natin yung idea or yung formula ng force, which is pressure times area. So, yung force on the bottom surface would be positive kasi alam naman natin na yung mga forces that acting upward should be positive. Then the force on the top surface, these are the force that are acting downward, kaya siya naging negative. So, importante din dito na ma-visualize natin yung idea about weight. Force is equals to mass times acceleration. Then mass is equals to density times volume. Pag pinagsama-sama natin yung and transposing some of the given, ang mangyayari dyan is ito. So ang mangyayari is, yung density natin is ito times natin sa volume na given nga sa figure natin is 1 by 1 times yung height. Then, ito times pa natin siya sa weight. And ang magiging basihan natin dito is yung gravity. Yung gravity yung magiging weight natin. Then, ang magiging final equation is ito. So now, dahil alam na natin to, meron na tayong 3 forces. Isa sa bottom, isa sa top, and isa sa weight. So, now that we have all the necessary equation, so i-consider na natin yung term na equilibrium. So, yung equilibrium is parang summation na siya ng lahat ng forces. So, mangyayari dyan is parang pagsasamahin mo na yung tatlong forces na nag-act dun sa given natin. So, dito nakalagay na yung lower surface, yung upper surface, then yung weight is equals to 0 na siya. So based on these 3 equations na pinagsama-sama natin due to equilibrium, pag inayos mo siya algebraically, makaka-come up tayo with the hydrostatic equation. Dito siya, ito yung magiging final equation niya na magagamit natin sa pag-determine ng certain things na need natin i-determine. Okay, so let's solve this problem. Calculate the standard atmosphere values of temperature, pressure, and density at a geopotential altitude of 14 kilometers. So, yung magiging working equation natin is the ratio of P, which is equals to E raised to negative G over RT times the difference of height. Then, since alam naman na natin yung constant pressure sa 11 kilometers, which is ito, 22606.82. Then, i-substitute na lang natin siya dito. So, yan. Then, itong GO, substitute natin lahat. RT, to 287.081 over kg Kelvin times the temperature, 216.66 Kelvin times itong difference in height. So, yan. So, lahat is na-substitute na. Yung difference in height will be expressed in meter, not in kilometers, kasi magkakamali yung solution. So, once na substitute na lahat, you can calculate it, and using your scientific calculator, you'll come up with the answer, this. So using that equation and substituting all of the values and computing it in our calculator, we can now determine that the pressure in 14 kilometers is 14,084.73. So, proceed tayo sa pagkuha sa density. So, here sa density, same equation, like, ang magbabago lang is, hanapin natin ang density in 11 kilometers. Then, isa-substitute lahat ng values na kailangan. The G, the RT, the difference in height, everything. Then, by using the calculator, we can get the final answer. The density at 14 kilometers is 0.227 kilogram per cubic meter. So, katulad nga nung past discussion, as the altitude increases, the pressure and the density also decreases. Okay, so let's solve the next question. So if an airplane is flying at an altitude where the actual pressure and temperature are 4.72 times 10 raised to 4 pascals and 255.7 Kelvin respectively, what are the pressure, temperature, and density altitudes? So in order to find the pressure, temperature, and density altitude, so i-identify mo muna yung given kung nasaang region siya. So based sa given, it is located in the gradient region. So yung magiging working equation natin dito will be derived from the gradient region. So in order for us to find this, gagamitin natin yung formula na ginamit natin kanina sa previous problem, which regards to pressure. So yung formula is P over P sub O is equals to 1 plus alpha over T sub O raised to 5.26. So, lahat naman ng parameters are given maliban sa pressure altitude. So, ito yung pagtutuan na natin ng pansin, itong H. So, para ayusin yan, so dito, in-input na yung mga given, then, in-isolate na yung H para malaman kung ano yung hinihingi. Then, pag na-manipulate na and na separate yung H and nalagyan na lahat ng na-input na lahat ng given, you can solve it using the calculator and lalabas na ang pressure altitude is 5,992.91 meters, which is equivalent, pag ni-round off, is 6 kilometers. So, pag pumunta naman tayo sa temperature altitude, kukunin yung equation ng temperature in function with the altitude. So, for us to do that, so ang ambient temperature is 255.7 Kelvin. That would be the base, the T, then ang given sa T sub O will be 288.16 Kelvin. And then yung lab state natin would be negative 0.0065. Then H is the unknown. We can solve it. Pag nalagyan na lahat ng given, and you can solve it sa scientific calculator, and nalalabas na ang temperature altitude will be 4,993.85 meters, which is equivalent to 5 kilometers. So, next, for us to identify the density altitude, what we're going to do is we can use the equation of state, like which is given here. Ito. So, dito, given a pressure and given a temperature, so ang hanapin na lang is tong rho r. So, in order for us to do that, i-manipulate mo lang yung equation, which is ito. Pressure is equals to PRT. Then, ilalagay mo lang lahat ng values, lahat ng given, which is 4.72 times 10 raised to 4 Pascal over 287.08 J over kgk times 255.7 Kelvin. Then, pag sinolve mo to, ang lalabas is 0.643 kilogram over meter cube. Next step is gagamitin nating equation is yung related sa density sa altitude, which is ito. P over P sub O. Tas yan is equals to 1 plus AH over T sub O, then raised to 4.26. After that, ilagay mo na lahat ng mga given, which is ito, then i-solve mo na with using the scientific calculator, and ito yung lalabas sa density altitude natin. Density altitude is equals to 6,224.83 meters or 6.22 kilometers.